Hello 108 students, Mr. McHugh back here with you on section 7.6 page 2. Now this time we're going to work with inverse variations. Okay, and so I have right here in my notes, I want you to think of it as the input increases, the output decreases via division. As the input increases, the output decreases. Y varies inversely as X. Okay, so what they've got here, you can look at and see Y is your output, K is the constant. Now you're going to divide by the input, not multiply, but divide. Okay, so you've got Y equals KX. Again, input, constant, and here's the output. Okay, now, okay, so I got it right here, didn't have to write it. Sometimes the input can be squared, by the way. Okay, and so I want you to think of this analogy. You're in your car, you got on the interstate, and you're getting ready to cruise. You're going to go to Salt Lake City. You start pushing the gas pedal. The farther you push down, what happens to your speed of your car class? Okay, you increase, right? You don't want to go past the speed limit now. What happens? You're cruising at 75, you're going down through Mountain Home, and all of a sudden you look up and you see a deer standing in the middle of the interstate. What are you going to do? Your first reaction is going to be what? You're going to hit the brake pedal. And the harder you hit that brake pedal, what happens to your speed? It goes slower. You slow down. Okay. Think of your brake pedal. You're cruising down Chinden Avenue, and I do this all the time. I've been going for a couple miles, and I see somebody on an access street kind of pulls out in front of me. I've been cruising at 55. What might I do? Well, I wouldn't necessarily slam my brakes on, right? I don't need to come to a complete stop, but I might just tap my brakes, just hit them just a little bit, so my speed slows down from 55 down to 50, and allow enough distance between me and the guy in front of me who kind of cut in front of me, but not a whole lot. Now, however, if he cut right in front of me, what would I do? I'd slam my brakes on, because the farther I push down on the brakes, the slower I'm going to go. Does everybody see that inverse proportion there? Okay, so here's another example here with it. Distance, this is just me here. It's not part of, just trying to get the concept going here. Distance equals rate times time. What if I asked you to solve for time? You would divide both sides by R. And many students I talk to in Idaho, they tell me, I go, how far is it to Salt Lake City? They tell me 5 hours. Hardly anybody ever tells me the exact distance. What are they doing in their brain? Because they've driven so far. I just moved out here back in 07, so I'm still learning. They took the distance divided by the rate that they go. And they tell you, oh, it's about 5 hours. How long is it to Portland? Oh, it's about 8 hours. Okay, they're taking the distance to Portland divided by the average speed you're going, the speed limit, and they're giving you that time frame. Now think about this. Let's just say you're going to Salt Lake City and you want to talk about time, and you say, well, if I would leave to go to Salt Lake City and my rate is miles per hour, and I would go 20 miles per hour. Oh my God. You'd be on a bicycle probably if you did that. If you're Lance Armstrong, you could kick out 20 miles an hour, and 300 miles divided by 20 would take you 15 hours to ride your bike to Salt Lake City. Okay, so there's 20 miles per hour, and now you're going to go ahead and decrease the amount of your speed from 20. Well, you're going to increase it from 20 to 75. You increase it, so you're going from 20 to 75. You're going big. What happens to your time? You go from 15 hours. You go from big to small. Okay, so hopefully everybody sees that inverse. As the input gets bigger, the output gets smaller, and vice versa. Okay, so with that said, again, these problems have 2 cycles to them. Look at example 4. Syringes, I think this is in the book. They tell you it costs for 10,000 syringes that are produced, it costs $2 a syringe. Yeah, this is on page 410. Okay. This is a business problem, by the way. Anybody going to go into business? This is a classic business problem here. 10,000 syringes cost you $2 per syringe. What's the cost for 25,000? For the cost for 25,000 is the problem. Okay, so this is in two parts. Take what's given to you. Take the fact that you know the cost is going to be the and you're told that it's inverse. Excuse me, this is important. In the problem, they are going to use the word inverse. That's how you know you're going to set it up as a division problem. The cost is going to be the constant divided by the number. Input, constant divided by the input equals the output. Not multiply, but divide. Okay, so here you go. $2 cost, constant, we don't know it. How many units? 10,000. Now, how do we figure out the K? Cross multiply. So you get K equals 2 times 10,000, and you got your constant is 20,000. Okay, now you have that. You're now ready to tackle on the problem. Think of your second cycle starting here. Well, it's your cost now that if you're going to not make 10,000, you're going to go double it. You're going to double production to 20,000. What would the cost be? So you take a 20,000 and you're going up to 25,000 units. So 20,000 divided by 25,000. A lot of you maybe could do this and go, ooh, cross out all those zeros. 5 goes into 24 times, 5 goes into 25, 5 times, it's 4/5, and you immediately say it's 0.8. Some of you guys can do that, I know it. So it cost 8 cents. Now, I just want to say, we see this all the time. We live in our amazing technological world. This happens all the time. As the number of units increases, the cost per unit goes down. That's what this is showing you here. Think of your flat screen TVs. Okay, 10 years ago, when they started making those big screen TVs, they were tons of money. They were extremely expensive, and then they kept getting more and more popular, and more popular. Now I walk around Kmart, geez, you can buy a 27-inch screen TV for $300. 27-inch screen TV back 10 years ago would have cost you $2,500 or something. So you could see as the demand increased, the productivity efficiency starts to kick in. Manufacturers can get lower rates on the parts. How their factories become streamlined and efficient, and they can lower the cost per unit. If they can lower the cost per unit, then they can lower the total cost of the price. We see this computers, it goes on and on and on. I can think of hundreds of examples here. So think of that inverse proportion on terms of that, and that'll help you out. Okay, hey, Mr. McHugh, I'm going to stop yakking here. Page 2 is done. We're into books. I will see you for our last page for section 7.6, and we're going to wrap up chapter 7. Okay, so I'll see you for page 3. Bye.